In the last video, we have discussed about the other families, that is, we have discussed about the baryons and hyperons, we have discussed about the strange particles, and in this video, we are going to discuss about the leptons. So, leptons basically contains electron, photon, neutrino, and muon. So why we have why we introduce these lepton family? Because all these elementary particles have masses that are smaller than that of a pion. So let us first talk about the electron. So it was the first ever discovered particle. It has a negative charge, it is a stable particle, and there always exists an electrostatic field. Why there is an electrostatic field? Because two electrons are always charged, and that is why an electrostatic field exists between those particles. So next, talking about the photons, as photons has no charge, it has no rest mass. So we have our Planck equation, that is E is equal to h nu, where h is a Planck constant and mu is the frequency. So the energy of photon can be given by this equation. And if we take about the Einstein equation, so it has an equivalent mass, that is, it's given by E is equal to mc square. Talking about the neutrino, so it was discovered in 1956, beta ray spectra in radioactivity. So it also has no charge and its rest mass is 0. It too travels with the speed of light. It always exists in two forms, one associated with electron and the other with the muon. As we have nu u, e, and nu mu, and we have the third category, that is nu tau, that also exists. Next one is the muon. So talking about the muon, it is similar to electron. So its properties are almost similar, but the basic difference is its mass is about 200 times that of an electron. Next one is it decays very quickly with a half-life of 2.2 microsecond into 1 electron and 2 neutrinos. It is a negatively charged, it has been half, and it was first discovered during the study of cosmic rays. In the cosmic ray discovery, it was introduced. So next comes the meson. So meson's masses lies between leptons and baryons. They are the unstable particles. They decay into lighter muons, mesons, or leptons. They can be either positive, negative, at zero charge. So mesons include pions, cation, eta, beta. So these all are the things that I had already discussed in the previous video. So next is a positive pion. So positive pions have mass equal to 273 times the mass of electron, and it's a positively charged particle, and its lifetime is 10 power minus 8 second. Talking about the neutral pion, it has no charge. Its mass is equal to 264 times the mass of electron. Talking about the charged cation, it is a positive charge and its mass about 1/2 of proton. Neutral cation has no charge and its life is of the order of 10 power minus 9 second. So these were all the information that we have to already know in order to discuss about the all other concepts. So next come to the article, that is particles and antiparticles. So what are these? Let's discuss, take the case of electron and positron. They both are having the same mass, and we know they both have the same spin. But the difference is they have the opposite charge, because electron is E negative and positron is E positive. So whenever there is an introduction of particle and antiparticles, so they both annihilate each other with the emission of photons. So we already knew the direction, that is E negative plus E positive giving to 2 gamma. The existence of an antiparticle for the electron was actually predicted by Dirac because of a symmetry of the equations of relativistic quantum theory of electron. So when we study about the relativistic theory, so it was Dirac who predicted that there must be some antiparticle in order to balance out the equations. So next one, the positron was, but actually its discovery took place in 1932 by Anderson. So it was discovered by Anderson. And same is the case for neutron and anti-neutron. So they both are particle and antiparticle of each other. Sorry, neutron and anti-neutron. So they both are the particle and antiparticle of each other. So they both have charge 0. They have the same mass, Antineutron is quickly annihilated either by a proton or a neutron, usually with the production of several pions. If an antineutron is not annihilated by a nucleon, it decays by the following reaction. The same case is with the neutrino and the antineutrino. Say they have the charge 0, spin 0, 0 rest mass, and magnetic moment similar smaller than 10⁻⁻8, Bohr magnetron nearly equal to 0. They have finite energy, momentum, and travels with the speed of light. And if we're talking about the spin, so spin of the neutron is opposite in the direction of its always motion. The neutrino spins are always in the counterclockwise, while the spin of antineutrino is in the clockwise direction. So here lies the